All right, welcome everyone. Today is October 2nd, 2024, and this is the Cluster API Karpenter Feature Group meeting. We are a sub-project at Kubernetes SIGs, and as such, we follow their meeting guidelines. So pretty light agenda today. The only topic that I had was that I put up a PR to change the charter for the feature group. Should be pretty uncontroversial. Basically just adjusting the language to make it explicit that we're looking at the enhancement as well, and also that we're going to look into experimentation and maintaining, the operator for the time being. And that we might use these meetings to kind of discuss maintenance and whatnot. So yeah, that was just kind of an action item that was holding over from one of the last weeks, or one of the last meetings. So yeah, I'm figuring things, things have and probably will continue to slow down. Um, I would like to start looking at like some experimentation work that I didn't get into before, which is basically breaking out the way that we're handling like machine recognition and everything. I want to try doing kind of doing this in an asynchronous manner. Um, and there was the other kind of ideas I was talking about last time, exploring, is it worth looking at the native versions again, or could we make some sort of, custom integration or whatever.
Mhm.
So, and I've also had more people reach out to me in Slack as well, asking about like how to get involved and whatnot. So at this point, I'm kind of advising people to try it out. Hopefully, as people start to find issues, we'll open bugs and start to work on them. But that's kind of my expectation for the next phase, which I'm guessing will probably be like at least until January. We'll be experimenting and maybe hacking on the enhancement and whatnot.
Okay.
So, yeah, I guess I don't have a lot of big stuff to announce otherwise, or nothing really from my side. Did you have any did you have any questions or anything you wanted to talk about?
No, I need to get in and poke at it a bit. Um, I do like the I do like the idea that we talked about last week of flipping it on its head, or last meeting. Um, so I'd like to I need to get in and look at it a little bit and play with it, do that kind of stuff. Um, I mentioned it just in passing to the AWS Carpenter team on Monday. They had a Carpenter Innovation Summit out here, and so I you know, mentioned that the way that it's currently integrating is through the machine pools, and maybe there was some talk of flipping it around around the other way. So, but that was just in passing. Um,
That sounds like a cool event though. Like, was that at Adobe, or where was it?
It was at the AWS office down in Santa Clara.
Oh, cool.
That was neat. It was um, we got a couple of representatives from Adobe there, and then there were other companies in the room just kind of talking through what they're doing with Carpenter. Um, few companies presented about how they're using Carpenter now. I presented on how we managed our migration to Carpenter, because um, we we built our migration strategy in a way that was that's really quick to execute, and it's really safe, and it's feature flag enabled, so we can just enable that flag and roll forward to it, or disable it and roll back, and no one actually knows we're doing it, which is nice. So that
Yeah,
was it
that's
was
really
fun.
cool. Yeah.
Um,
So I
they sorry, go ahead, please.
No, no, no. Finish what you were saying.
They went through the 1.0 features and explained all of the new disruption budget stuff, and took solicitations for features that we want, and a ranking on them. Like for Adobe, some of our top priorities are full support for ODCRs because we use ODCRs in a very specific way that doesn't allow us to just wrap it up at the account level. We need to be able to isolate it to like individual clusters or individual worker tiers in a cluster or node pools in this particular case. So as ODCRs, support for custom pricing, both of those are coming soon. And then things like node count limits. We've got, and other companies there, talked about the fact that we do have needs for hard node limits on clusters. We can't just go with this, okay, we'll do 12,000 cores kind of thing. It's like, no, we need to tie that to a node count. And so just kind of asked for a feature like, as you start to approach these limits, whether you're monitoring IP space to make sure that there's IPs available or monitoring a hard limit as we start to go up in node count, could we look at swapping out instance sizes, like smaller instances for bigger ones? So we don't get into a state where we can't schedule things, but so we also don't break our clusters, because it is kind of a challenge with us. Most of our clusters don't really hit our self-imposed 500 node limit, but we have a couple that do, and that gets really tricky to manage with multiple node pools, because we have one general node pool for ARM, one general node pool for AMD. They both match on multiple instance types. Then we have a memory optimized node pool for legacy reasons, and they all have limits that are calculated at our smallest node size has this many CPUs, so divide that up, and this is the number of resources that node pool can consume. But those are separate counters for each node pool, so realistically we're kind of tuned to burst up to 1,500 nodes, and that's 1,000 nodes over where we want to be. So there's just very clunky ways to deal with that, like looking at creating a node pool with that's bound to smaller node types, node sizes, that has a smaller limit, so with a higher weight, so that fills up first, and then after that's full we spill over into bigger node pools. But we haven't really done a lot of experimentation with that, and it seems a really clunky way to do it, instead of just saying, give me a way to set a hard limit on nodes.
Yeah, no, exactly. And especially given the way Karpenter wants to operate, how it wants to just kind of automate all that, and like you don't have to think about it. Yeah, like having it do something where it's like, I want you to respect the number of nodes that you've put into the cluster. That probably breaks their model a little bit.
It does. And it's like they talked about, someone asked, can we have a controller around disruption that considers node utilization amount? And they said, no, not really, because that's not the way we think about things. And they've got a little bit of a language issue with their configuration on disruption, right? Because you can disrupt, with 1.0, you can set your disruption budgets, and you can, set when that happens, whether it's underutilized or when empty. And they say underutilized, but what they really mean by underutilized is cheaper alternatives, right? And so they're like, yeah, that's true, because you could have a consolidation event where you have a node that's at 99% utilized, and we identify that we can run it on a cheaper node, which would also be at 99% utilized, and we will disrupt that, right? Because that would be identified as underutilized, but that's really the wrong word to use for it. I don't
Right.
know if there is a better one, like cheaper option
Right.
or something, but
Right. Well,
and that's
it's almost like under optimized if cost is your optimization or something, right?
yeah, and that's been something that I've had to remind people of a lot as we roll out Karpenter, is that cluster autoscaler is going by utilization, and our basic configuration for cluster autoscaler tries to reclaim nodes when they're under 50% utilized. And it does it, every 15 minutes or every 90 minutes, like however we have that configured. And then Karpenter isn't thinking, it's like apples and oranges. It's going by cost. It's not going by utilization. And so when we start looking at some of these clusters that we've migrated to Karpenter, it gets weird because they say, well, our CPU efficiency didn't really move. And it's like, yeah, but that's not the right metric to look at. You need to look at how much that CPU is costing you. So we could have ended up with worse utilization. Like on some of our Argo CD based clusters, right? We have 95% memory efficiency and 20% CPU efficiency. And it's really swapped all those instances out, and it's biased towards the R series now. And, you need to look at that in terms of like cost per unit that matters in that case. And we usually think of that in CPUs, but in these cases, you have to look at memory. And the R series is cheaper per megabyte than the C series. And so what did that do to our costs? It's like, well, I don't know, because we're not thinking about it in that way. We need, we need a metric that will give us the cost of every instance that we're currently using, or that we ever use over time, with the number of CPUs in each of those instances. Then we have to add it up and divide it. So if we get the raw cost per core, right, and we just watch if that goes up or down, and then we know if the cluster is more efficient or not. But we're not doing that calculation at the moment, and I'm not even sure that's the best way to do it. It's just, we can't go by raw cost on the cluster, because it could go up and down based on the number of nodes, and we need to be able to normalize that. I don't know if we have that really built in anywhere.
Yeah, these are like some of the tough challenges when using any of these tools, right? It's like it's almost like kind of the Dutch dam problem, where it's like, you put your finger in a couple holes and then more open up, or like you can never cover all the bases exactly like you want it,
Yep. This does make me think, though, like, and I guess it's something to get in and play with the proof of concept work that we have, where Karpenter is looking at Kappa as the cloud provider on that. Now that they're doing things like adding disruption controls and schedules and budgets and all that, right? Like we can set a budget that says you can disrupt 10% of the cluster at any time between like 7 and 9, but then you don't disrupt anything from 9 to 5. And then it's, open season over the evening hours. Like, how do we tie those lifecycle kinds of configurations back to lifecycle configurations that we set in Kappa?
Yeah.
Like now we have, two different places where that can be configured. And that could get a little weird.
Yeah, absolutely. And I would love to see us kind of like figure out what that weirdness is and what does it look like, so that we can better surface it. Because I think the community was kind of convinced that they wanted this like rich cluster API experience. And I think like what you're talking about now is like, okay, that's where the rubber meets the road. It's like, is this really what we wanted? Like, do we want to have this split brain thing where like Karpenter controls some aspects of the life cycle and cluster API controls other aspects, and maybe there's some overlap between them and we got to figure that out? Or do we want it to be like, do you want Karpenter to be managing the life cycle and cluster API is kind of like a detail? Or maybe the other, like it doesn't make too much sense to go the other direction, because then what's Karpenter doing,
Yeah. Oh yeah. They, with the disruption budget stuff, they've also added controls where you can set, the max TTL on a node. So Karpenter will, start gracefully terminating them after like 72 hours and then forcibly terminate them, and so now we have those controls there as well. So Karpenter is managing lifecycle when it didn't but before. Cluster API is managing lifecycle. Yes, how do we get those two together? I kind of like, the more I think about it, the more you know, um, cluster API, just, querying Karpenter objects and somehow importing those so it knows about them kind of makes a lot more sense there. And just keeping those configurations kind of separate in a way, but that level of integration becomes tricky. Like our migration to Karpenter, we really take advantage of the fact that cluster API, the schedule, or uh, cluster autoscaler, the scheduler, and Karpenter, they're all just very loosely coupled. They don't really know anything about each other, and that's extremely beneficial in this case because we can have cluster autoscaler and Karpenter running at the same time. And we still have them running at the same time. We've just tainted everything. So cluster autoscaler no longer recognizes the ASGs as valid targets except for the Karpenter deployment. So it manages two nodes now. And they clean up after themselves. So after we migrate, the cluster autoscaler nodes slowly burn off and it scales everything to zero. And if we have to roll back the other way, the Karpenter finalizer cleans up everything else on that side. And the fact that they just kind of sit around and wait for the scheduler to say, I can't schedule this, makes that easy. We don't have to do any cross, configuration. We don't have to do anything weird to make it work. We just, we just have Karpenter and cluster autoscaler doing what they normally do. And the scheduler doesn't really care where compute comes from. It doesn't really know where compute comes from. It's just like, oh, there's empty space there. I'm going to use that. And the Karpenter team clarified that they used to bind pods to new compute when they launched them, and they stopped doing that. I don't know when they stopped doing that, but you still see that relic in the logs of nominated. This is the nominated node, but they're not really nominating it. They're just like, it should schedule there. We think it will. And they also confirmed that, yes, there is a possibility that the scheduler that, Karpenter provides new compute, and the scheduler in the meantime could say, oh, there's new compute, and shove something else in there. So the thing it was trying to schedule doesn't actually schedule there, right? And they said, but, performance went up and results got better after we stopped telling, it where to go. And it's like, yeah, let the scheduler do its thing, let Karpenter do its thing, let cluster autoscaler do its thing. And so where is that, I guess the thing would be, where is that nice middle ground between Kappa and Karpenter in that case? Like, where do we really see that kind of, graceful coexistence thing like happening?
Yeah, absolutely. That's why I want to spend like the next, I'm hopeful that we can spend the next quarter or so kind of experimenting, trying out different patterns, and hopefully through that, and as I'm kind of coming into contact with more people who are actually starting to experiment with it, I think that's going to help to inform us about, okay, what is the best experience for people using this tool, and where's the sweet spot, and what do we still need to do to make it better? So I'm hoping that we'll start to collect these user stories over the next, several months and whatnot, ideally.
Yeah. I'll see if I can get some time in the last, part of this year to really do some good experimentation and digging into that, because we're coming up on, change restrictions with the holidays and all that. That's going to start rolling up soon. So it's a great time to, do things that aren't tied to releases, because we can't do any releases.
Yeah, for sure. Well, I look forward to whatever you find. I'm sure the experience from your perspective is going to be very different because, you're getting a lot of success and usefulness out of Carpenter AWS right now. And this, this Cappy one is going to be like much less featureful, but still I'll be curious to hear like kind of what you get into with it. So I hope it works out.
Yeah, I mean, Mike's point about a single pane of glass, single control point for everything is, I think that's really valid and is going to be extremely useful. But at the same time, it's like, yeah, Carpenter has made our migration, potentially to, our potential migration to Kappa a lot easier because we've just simplified our infrastructure entirely. And so now we don't have to go import all of these ASGs and worker tier configurations into Kappa. It's just Carpenter is taking care of it. And yeah, I'm curious, like, okay, so now I have to go create machine pools and everything. So now I do kind of have to do that,
Right.
and so how much complexity are we embracing there? And the simplicity that Carpenter brings is it's new, it's kind of scary, but it's very powerful. And do I really want to get into explicitly defining everything, or am I cool with Carpenter? Like we could set Carpenter up on AWS so it will use any instance type that AWS provides. And I think the count that they said was like 820 something instance types
Wow.
available. We are nowhere near using, all of that. But when you look at, the what would it be? The fifth gen AMD offerings, the C5, R5, M5, and then the Graviton 2 offerings. Those are major, buckets there, not counting like GPU, varieties. When you start getting into all the sizes available and all the variations, it's like, oh no, this is a lot of stuff. And we've had issues with some tenants post migration where, like we had a cluster that was only providing C5 9Xs, and we had a tenant that was doing builds on that. They were really happy with that. That worked fine. Carpenter came along and was like, "You fit much better and more cheaply on an M5-4X." And the EBS bandwidth on the M5-4X is, I think, less than half of the C5 9X, and you don't even get to a comparable bandwidth, EBS bandwidth, until you get to, I think, a 12X on an M5. And so they, raised a CSO over that because now their performance was really bad. And we've never thought about having to have a specific threshold on EBS bandwidth, right? We don't have anything that says what we officially support on that, but because we had it and they used it, it's like, I guess that's a feature we support now.
Right.
You know, and so we had to, kind of limit Carpenter on that cluster at first and have them select for a specific instance type. We're trying to get to .337 now, because I don't know if it exists in the earlier versions, but it only showed up in the documentation. And .37 is the ability to, select on performance properties for instances. So it's like if you want 9600 megabit EBS bandwidth, select for it and then let Carpenter find the cheapest solution for you. Let's do it that way. And I can't wait until we can do that, because then maybe we'll get that cluster, more efficient again, instead of them, binding to a C5 12X at this point, and only using like half of it, right? So
Right.
there's a lot, there's a lot of potential there and a lot of variability. And I guess coming back to the original point, how much of that configuration do I actually want to manage versus being abstracted away from it and being able to just go to AWS and say, give me something with this amount of network bandwidth, this amount of EBS volume, and this root device size. Go figure it out.
Right. Right.
I do like things being explicitly defined, because then we avoid this problem. But you know, um, having that abstraction layer, can really be a force multiplier for, moving forward, and not having to do toil work on, cluster tuning.
Right.
So
Yeah, I mean, and that's Carpenter's, like one of Carpenter's seriously powerful elements that you kind of already, kind of pointed out, which is it's great at just digging through the inventory and pulling stuff out. So like if you're willing to let it do the magic, right? Let it, take over. Yeah, it can find all sorts of wild stuff in the instance inventory there. So, but I guess the other side of it too is like you get into these weird performance things where it's like, yeah, this series of instances has some weird like behavior with relationship to like, yeah, storage IOPS or something like that. And
yeah,
then it's like, where did that come from?
and it it starts turning, a lot of your configurations like on their head as well, because we bound our node pools to only provide like 8x and larger, because of node limits. It's like, okay, that's great, but if you look at a C5 9x and an M5 8x and an R5 8x, the network and EBS speed on the M and the R's are not equivalent to the 9x C5, and they don't get there until you end up at the 12x.
Oh,
So
wow.
with those breakpoints being in different places, we can't just say, well, anything 8x and up is good. It's
Right.
like that's not the case. We have to look at these other properties, and we have to have those available, and we have to start educating people on selecting those properties. Like, if you want this, do this particular thing. Um, someone someone in the summit brought up the use case of, I want to be able to have a setting where a tenant can deploy a workload on on the cluster and have it almost automatically add a taint to whatever node it ends up on, so nothing else gets scheduled there. And it's like, wow, we don't actually have a setting anywhere in Kubernetes where we can do that. We have anti-affinity settings, but you would have to, have everyone else add the anti-affinity against you. You can't set your anti-affinity to say don't live with anyone else, because the scheduler is still going to try to target that.
Right. Right.
And that's an interesting, use case. Like, we need to be able to schedule something and then prevent other things from scheduling there. And that would make configuration a little bit easier in cases where we have like Envoy, and we know Envoy can be extremely chatty and drown out everyone else that wants to talk. And so we can have our tenants create an anti-affinity rule that says stay away from Envoy. They can do that. But we can't just deploy Envoy and say keep everyone else out, unless we create a dedicated tier for it, a dedicated proxy tier, and add a taint, which is what we do. But it would be kind of neat to be able to just deploy a pod and say keep everyone away from them. And so if that pod dies, or if people tolerate that, they can, select into it, but we don't have to go create an explicit node pool just for that service.
Like, yeah, the selfish option or something on the
Yeah,
POSPEC,
but that also gets incredibly dangerous, because like we try to restrict dedicated worker tiers or node pools, because tenants, we don't have a way to bill that back, to attribute that cost, directly to those tenants. And if they're doing something very wasteful on it, it can get expensive. And if we provided this option to tenants that they can, taint a node to keep everyone else out, I can see that being extremely, extremely wasteful. It's like when, tenants have a, you know, host host anti-affinity, and they have a topology spread, and then they scale up. And so now we have like 50 nodes just for one of their pods, 50 nodes with one pod each on each thing. It's like, don't do that, but we let them.
Totally.
Yeah.
Oh man, this is definitely like Tales from the Front Lines, for sure.
Yeah. We had one, or we've got one. It's a really weird deployment where they have a 10% PDB, uh, uh, 10% unavailable PDB, a host name anti-affinity with a schedule anyway, and a topology spread across 3 AZs with a max skew of 1 and a no schedule. And so when they scale up, Karpenter treats that host name anti-affinity as absolute, right? So you have this big spike of nodes, and then it wouldn't be able to ever consolidate it because it has a 10% unavailable like PDB, so it's not going to be disrupted. But their deployment restarts like every 5 minutes or something. It's weird. The pods don't restart in place. The whole thing gets restarted.
Wow.
So it does this big spike, and it starts playing with our node limits. Like it gets up to 500 nodes, this is the cluster where we kind of need that hard limit, which we don't have with Karpenter. And then it restarts, and the scheduler, because there's a schedule anyway on the host name anti-affinity, it packs all those pods on nodes with other pods of the same type. So then you end up with like 7 of those pods stacked on the same thing. So
Weird.
it's like, you don't need this anti-host affinity, obviously. And then Carpenter scales everything down. It's just really weird. And we're Carpenter, the speed at the disruption exposes all these weird things that happens. And it makes it like, okay, you have a topology spread against 3 AZs, but a 10% PDB, shouldn't your PDB really be 33%? Like it, we need to start adjusting these, and to get Carpenter efficient. And it's weird. There's so much weirdness that we're finding now.
Absolutely. I mean, I guess that's what the name of the game is at this point, right? Finding the weirdness and then figuring out how to make it less weird,
Mm-hmm. And figuring out all these like settings and configurations and everything else that can deal with the weirdness, so we don't break things accidentally as we move forward.
Right. Because you can't bring down the entire production pipeline or whatever because of some bizarre interaction.
Right. And then I I that gets into the Cappy Karpenter relationship as well, because now if we have conflicting settings between the two of those, we've just multiplied our weirdness
Right.
and our
Which one
inability
gets
to
obeyed,
track
right?
those down.
Yeah, for sure. Well, I realize we're like 5 over at this point. I hope you
Yeah.
have another meeting to go to.
No.
But it was good talking with you, and like I'm always curious to hear these kind of operational stories and whatnot, because I think it's kind of like at the core of what we're trying to do is make these things better and less confusing to work with and everything. So
Yeah. So I'll see if I can get some time to start playing with this a bit, so we can, I can contribute a little bit more in that direction.
cool.
Because we are going to Kappa, we are going to Karpenter. Eventually, they're going to have to play together. Got to figure out what that looks like.
Yeah, absolutely. Look forward to hearing it.
Cool.
All right. Well, I guess have a good one, and I'll see you around online probably.
Cool. All right. Have a good one.
Yep. Later, Jeremy.
Bye.